Okay, today's video we're starting on page 10 of our chapter 8 notes packet. We'll be completing the notes packet, finishing pages 10 and 11. Solving logarithmic equations. Let's think about this. If we have log base b of x is equal to log base b of y, then what do you think is true? All right, same bases. So x and y are also known as arguments. So these arguments must be equal. So x must equal y. Recall our log rules. When condensing, if we have log base b of x plus log base b of y, to condense to a single log, this would equal log base b of, remember, addition meant it was multiplication to begin with. So this would be log base b of x times y. Number 2, log base b of x, subtract log base by. Condensing to a single log base b, if we have subtraction, that meant it was division to begin with. X divided by y. And n times log base b of x, this multiplier of n was a exponent or power to start with. So that's equal to log base b of x to the n. When solving a log equation, sometimes you're going to have to condense first, like you have two logs on one side and one on the other, all right? Other times you're going to have just equal logs, so you're going to drop the logs and just set the arguments equal to each other. All right, but let's see. If you are solving an equation with more than one log term on one side, condense that side. If there's more than one log term on one side of an equation, condense that side. If a log term is on both sides of the equation, use the fact that if log base b of x is equal to log base b of y, then x is equal to y. If a log term is on only one side of the equation, you're going to rewrite the log equation as an exponential. After you found the values of x, check to see if it's extraneous. Note, the argument of a log term must be positive, must be greater than 0, must be positive. This does not necessarily mean that x itself must be positive, but rather the argument must be positive. Okay, we want to solve for x, rounding to nearest tenth when necessary, and check your results. Number 1 here we have log x plus 1 is equal to log 12. All right. So we have more than one log on the left-hand side. So we want to condense this into a single log. So this would be log. This addition here between the two logs meant it was multiplication to start. So this would be log of x times x plus 1 equals log of 12. Okay, now we have logs on both sides. So that means that this argument would have to equal this argument. So just drop the logs. X times x plus 1 would have to equal 12. Now let's solve this. Distribute x squared plus x equals 12. Put it in standard form because we see that it's quadratic, so we subtract 12 from both sides. And now we factor. Factors of negative 12 that add to 1 are 4 and negative 3. So x plus 4 times x minus 3 equals 0. Set each equal to 0. I'm skipping that step, going right to the two values of negative 4 and positive 3. Now we check. We go back to the original. If we plug 3 in for x, okay, log 3, so 3 is positive, that's okay. 3 plus 1 is 4, that's positive, all right. If we substitute negative 4 in for x, We have log of -4. No, the argument here has to be positive. So the -4 is rejected. That's extraneous. So our only solution here is an x value of 3. Number 2, we look at this. Right away we notice that there's 2 ln's on the left-hand side. So right away we condense. All right. So the subtraction between the 2 ln's meant it was division to start with. So we have ln of, so the single ln of x plus 1 divided by x minus 3 equals ln 5. All right. Now we have ln's both sides, so that means that this would have to equal 5. So x plus 1 over x minus 3 would have to equal 5. And I'll write that 5 as 5 over 1. And now we're set up to simply cross multiply. Cross multiplying, I have x plus 1 is equal to 5 times x minus 3. You didn't have to show that step. You could have gone right to the 5x minus 15. All right, this is nice. It's linear. It's not quadratic. So I'll subtract x from both sides and then add 15 to both sides. Not showing those steps. X equals 16. I'm sorry, 4x equals 16. And now finally dividing by 4, x equals 4. And we'll check. All right, we go back to our original. 4 plus 1 is 5. Okay, that's fine. That's greater than 0. 4 minus 3 is 1. All right, and that's okay. So x equals 4 is our solution here. Number 3, looking at this equation, we have 2 logs on the left-hand side. So right away, we're going to condense. Right? We're condensing the left-hand side into one single log base 2. All right. The subtraction between our 2 logs meant it was division to start with. So I'll write the fraction bar for division. The denominator is 9. The numerator, all right, this 2 out in front meant this multiplier of 2 meant it was an exponent of 2. So we have log base 2 of x squared divided by 9 is equal to 4. All right, so we have just a single log here. Right? We don't have a log base 2 on the other side. Okay, so this is when we're in log form. Can't really do anything with this as it is, so we're going to switch to exponential form. Right? From up above, if a log term is on only one side of the equation, rewrite the log equation as an exponential. Okay, so log base, so 2 is our base, this is our answer, and 4 is our exponent. Right? If you need a refresher, so base is 2, exponent is 4, and our answer is x squared over 9. All right, 2 to the 4th is 16. 16 equals x squared over 9. We want to get x squared by itself, so we multiply both sides by 9. And I have 144 is equal to x squared. Sorry about that. Can't see it. Here you go. X squared is equal to 144. So now we take the square root of both sides. So x equals plus or minus 12. All right. Positive 12 as an argument, that's fine. But negative 12, no. Remember, the argument of a log term must be positive. So our answer here is simply 12. Next, number 4. Again, looking at this left-hand side, we have 2 log terms, so let's condense this right away. You see that and condense. So this is going to be a single log base 4. Again, the subtraction meant it was division. This multiplier 2 is an exponent of 2. Alright, so we have log base 4 of x squared over x minus 3 equals 2. This is a single log term. We're in log form. Let's switch to exponential. So our base 4 exponent 2 equals our answer x squared over x minus 3. That's 16, and I'm going to write that as 16 over 1. So I'm setting myself up for a proportion. So now all we need to do is to cross multiply. X squared is equal to 16x minus 48. Standard form for this quadratic equation. Running out of room here. Factors of 48 that add to negative 16 are negative 12 and 4. Negative 12 and negative 4, excuse me. So it would be x minus 12 times x minus 4 would be our factors. So our two values for x, I'll go right to those values of 12 and 4. All right. Go back to the original, plugging in 12, that's okay. 12 minus 3 is 9. Substituting in 4, that's good. 4 minus 3 is 1, okay. So it checks. So two solutions here, both positive 12 and positive 4. Next page. Number 5. We have two ln's on the left-hand side, so let's condense to a single ln. Ln, the plus sign between them, and it was multiplication, so that would be ln of x times 1 is equal to 3.5. X times 1 is simply x, so ln of x equals 3.5. And if you don't recall, remember, ln is equivalent to log base e of x is equal to 3.5. Alright, so we're in this log form, so let's switch to exponential. Alright, base e to exponent 3.5 is equal to x. Go to the calculator, e to the 3.5. And looking back at the directions from the other page, it says round to nearest tenth when necessary. So that'd be 33.1. So x equals 33.1, which is certainly greater than 0, certainly positive. Number 6, and we've got two ln's here, so condense. The subtraction meant it was division. Okay, now we have ln3 on the other side. All right, good. So we have log terms on each side. So we can just set the arguments equal to each other, meaning x plus 1 divided by x minus 3 would have to equal 3. And I would express the 3 on the right-hand side as 3 over 1 and cross multiply. So x plus 1 is equal to, the cross products are equal in a proportion, remember, 3x minus 9. This is linear. I would subtract x, that's 2x. And maybe I'll just show that. I subtract x and add 9 to both sides. I get 2x is equal to 10. Divide by 2. Oops. Excuse me. This was an 11. Hope you caught that. Sorry about that. This would be x plus 11. X plus 11. X plus 11. So now when I add 11 plus 9, I get 20. Apologize. All right, now dividing by 2, x is equal to 10. If we take 10 and go back, 10 plus 11 is 21. Okay, there. 10 minus 3 is 7. Okay, there. Next, number 7. And by all means, you're more than welcome to pause the video and try on your own. All right. I'm looking at the left-hand side here. There's more than one log, so let's condense to a single log. So this is log base 5. The addition between the two logs meant it was multiplication. So of x plus 3 times x minus 3 is equal to log base 5 of 16. We have logs on both sides of our equation. So that means that the arguments, this would have to equal 16. I'll FOIL this at the same time. So I have x squared plus 3x minus 3x minus 9 is equal to 16. If I add 9 to both sides, I'll get 25. Or for those of you who prefer to factor, you would subtract 16 from both sides and get x squared minus 25. I'm going to add and then take the square root of both sides, so x equals plus or minus 5. Positive 5, that'll be 8, and 2. Negative 5, that'll put us at negative 2 right there, so no. The negative 5 must be rejected. So our answer is only positive 5. Number 8. Again, right away I see the two logs on the one side, on the left-hand side, so we'll condense. And the plus meant it was multiplication. So x times 2x minus 1 equals nothing on the other side but 0. So this is where we have just a single log, all right? We'll switch to exponential form, okay? So base is 4, exponent 0 equals x times 2x minus 1. Well, 4 to the 0 is 1. So 1 equals, and we'll distribute here, 2x squared minus x. It's quadratic, so we need to put it in standard form. I'll subtract 1 from both sides, give myself a little more room, move over to here. 2x squared minus x minus 1 equals 0. Now, trinomial lead coefficient's not 1, it's 2, so we have to do our factor in, factor out. So I multiply 2 times negative 1 is negative 2. Factors of negative 2 that add to negative 1 are negative 2 and 1. We multiplied by 2, we need to divide by 2. So this is just a middle step here. 2x minus 2, 2x plus 1, and 2 divides evenly into our 2x minus 2. It goes in x minus 1 times. So I have x minus 1 times 2x plus 1 is equal to 0. So these are our factors. Set each equal to 0. I'm going to skip that part, go right to the answer. X equals 1, and x equals subtracting 1 dividing by 2, negative 1/2. All right, go back to the original, and x value of 1, and 2 times 1 is 2, minus 1 is 1. All right, that's still positive arguments. Negative 1/2, nope, right away. Our argument there would not be positive, so this is extraneous. We reject this. And our answer is just x equals 1. Pardon me. Number 9. Right away condense into one single log. So this is log addition, then it was multiplication. 3x minus 2 times x minus 1 equals log 2x. All right, we have log on both sides of the equation, so that means we just drop those and set the arguments equal. So 3x minus 2 times x minus 1 has to equal 2x. No, that makes it worse. Sorry about that. FOIL, I'm going to get 3x squared minus 3x minus 2x plus 2 equals 2x. Combining like terms, 3x squared minus 5x plus 2 equals 2x. Subtract 2x from both sides, 3x squared minus 7x plus 2 equals 0. Alright, so I finally have it in the standard form, our trinomial, factor in, factor out method. Multiplying, we get 6. And the factors of 6 that add to negative 7 are negative 6 and negative 1. Let's see. 3x minus 6, 3x minus 1 divided by 3. And 3 goes into the 3x minus 6, x minus 2 times 3x minus 1 equals 0. Set each factor equal to 0. X is going to equal 2 and x is going to equal 1/3. Let's check back to the original. If I put 2 in for x, that's 6 minus 2 is 4. That's positive. 2 minus 1 is 1. That's okay. But 1/3, all right, our other value was 1/3. If we put 1/3, subtract 1, that's going to give us a negative 2/3. So we have to reject 1/3 as extraneous. And our answer here is 2. Alright, and again, pause the video, try 10, try the last one. I know we're running over 20 minutes already, but practice. Condense here, log base 4. The subtraction meant we had division of x squared plus 3x over x plus 5 is equal to 1. Single log, we're in log form, switch to exponential. So our base 4 to our exponent 1 is equal to x squared plus 3x over x plus 5. 4 to the first is 4. I'll express that as the fraction 4 over 1, setting us up for a proportion, right? So then we can cross multiply. So we have x squared plus 3x is equal to 4x plus 20. Subtract 4x and subtract 20. So we have our quadratic in standard form. Nice. The factors of negative 20 that add to negative 1 are negative 5 and 4. So x minus 5 times x plus 4 equals 0. And set each equal to 0, and we get two values. We have x equals 5 and x equals negative 4. Just a quick check. I know putting positive 5 in, that results in a positive value. Same here, that'd be positive 10. If I put negative 4 in, now negative 4 squared is going to be 16. And then plus negative 12, positive 16, negative 12 would still be a positive 4, so that's fine. And negative 4 plus 5 is positive 1. So both values, 5 and negative 4, are solutions. And that concludes our video. Thank you very much.